Hi everyone, myself Pranjal Saxena. I am currently a second year PhD student in aerospace engineering at IIT Kanpur. So today I'll be explaining you about my code written in MATLAB that helps you export meshes created in Abaqus to MATLAB. Let's get started. So this is our function read mesh Abaqus, and it has the following three inputs: file name, element type, and the mesh correction type. And it has the following four outputs: node, element, boundary node, and the boundary elements. So what it essentially does, it first reads the mesh data, the nodes and the connectivity info, irrespective of the element type, and then it divides it into linear elements and the quadratic elements. So for linear elements like T3 in triangular elements, we have named it, and H4 for tetrahedral elements, then it will further dive into the mesh correction type. If the mesh correction type is 1, it assumes that there are no boundary nodes, while for mesh correction type 2, it reads all the boundary data, so it does not do any correction in linear elements. While for quadratic elements, it updates all the mid nodes of all the elements when mesh correction type 1 is selected, while for mesh correction type 2, it only updates the nodes which are interior to the element. What do we mean by interior elements? So let's say we have this domain, so it's a quadrant of a circle, so it has these 5 elements, out of which 1, 2 and 3 lie on the boundary and 4 and 5 remain internal. So distribute this domain into two parts: the internal domain of elements comprising 4 and 5, and the boundary elements comprising of 1, 2 and 3. So if mesh correction type 1 is selected, we'll update all the mid nodes of all the elements. But if mesh correction type 2 is selected, we won't touch these green nodes. These lie at the boundary, and we want to save the curvature effect. So this gives us the advantage of having a curved element at the boundary, which is much closer to the actual geometry than a linear counterpart. There is one caution while using mesh correction type 2, because boundary elements and nodes should form a complete array. It can happen that the number of nodes at the boundary or the number of elements at the boundary are not suitably arranged in a form of an array. It may have some missing numbers. For example, if I am having this n set represents the nodes at the boundary and the EL set represents the elements at the boundary. If the nodes at the boundary are 2, 3, 4, 5, 8 and the elements at the boundary are 1, 2, the corresponding output will be like this. But if our nodes at the boundary are given in the form of an array, this primarily happens when we are dealing with smaller mesh sizes, then there are a lot number of nodes at the boundary, then it can happen that it does not form a complete array. So here, if the number of nodes would have been 6, then it would have found a complete array. But since the number of nodes at the boundary are 5, so it forms an array like this. And our code is unable to read this complete part. So then the boundary node will be null, which is not ideal. So extra care should be taken. We should add an associated large number to this, which automatically is filtered later on in the code. So whenever we are having an input file, we must check the number of entries should be forming a complete array, not a partial one. So a quick comparison between the mesh correction types 1 and 2. So for the mesh correction type 1, we'll be having all these straight edges. Now node 8 is now the midpoint of 4 and 3. Similarly, 5 is the midpoint of 3 and 2. While earlier in the original input file, 8 was lying on the curved boundary, and similarly 5. So in the mesh correction type 2, we are preserving these boundary nodes, even though they are mid nodes, while we are updating all the mid nodes in the interior elements. So this is one advantage of using mesh correction type 2. Similarly for 3D, these are just a 2D illustrations of a 3D geometry. It's a octant of a sphere, and you can clearly see that they are all straight edges here, while curved elements and the curved edges are preserved in the mesh correction type 2. So let's quickly now dive into MATLAB implementation. I'll just show you some quick demonstration about how to use the code. So this is the MATLAB program that I have written. So this is an adapted version from a GitHub contribution from Wong Ji. So now let's see the details of it. The first part actually comprises of reading the data. It uses the file read function and then splits and similarly find the nodes and the elements. Now it switches to the element type. So it decides whether it's a linear element or a quadratic element. So for linear elements, if the mesh correction type 1, then there is no need to do anything. But for mesh correction type 2, it can actually reads the boundary data. Since the boundary nodes have some arbitrary high numbers that we actually added in the .inp files manually, so this part of the code eliminates that part. So if it is less than or equal to number of DOFs, the number of degree of freedom, then it is an valid entry. That's why I asked you to add a arbitrarily high number. It need to be more than the number of degrees of freedom of the .inp file. So this filter is actually very helpful. Then for quadratic elements, for T6, if the mesh correction type is 1, all the mid nodes are 5, 6 and 7. So these are updated. While for mesh correction type 2, only the boundary nodes are left and the remaining are updated. For the remaining also, we will have to figure out which node is at the boundary and which node is at the internal. Similarly for the higher dimensions. In the end, what we do, we just take this part. Because we don't want the node numbers and the element numbers, it's already taking a lot of memory, so we don't want to use extra memory, so we just take the node coordinates and the element connectivity info. A small program about how to plot the mesh is also written. So it currently supports T3, T6, H4 and H10 elements. So it just decides the order of the nodes and then it connects it through straight lines. So now quickly let's dive into the main file. So here we have this mesh file. It's already saved in this folder. You can see it here. The mesh file should be in the same folder for the code to work. The inputs are the file name with .inp. Then the element type, it's T6, the quadratic triangular element. The mesh correction type is 1 and the dimension is 2. So this is our main function. So I'll just run it once. So this is the plot mesh function that I have already shown you. And this is some extra part. For dimension 2 and 3, it just adds the node numbers to the plot. So this is the plot that you will be getting. I'll just zoom out a little bit. So this is the triangle that you will be seeing. And then a 2-line code for saving the file. Now instead of this, if I do mesh correction type 2, then you will see that all these straight edges will be gone and you'll be having some curved. See, so this is the curvature induced. Now if I'll just open the .inp file as well. So here this n set and element set actually decides the nodes at the boundary. So if I just add one arbitrarily high number, let's say 100, and I'll just save and run. Here again you will see that the boundary node does not contain 100 because of the filter. Again, for one more example, what I will do, I will just make it an array of 2 by 3. Then again I will run. Again you are getting same, but if I remove this 100, so now it's not a complete array, and now if I run, you will be getting boundary node as 0. This causes an issue. So always you have to maintain an array in n set and the element set. So please be careful while using this mesh correction type 2. For mesh correction type 1, all the elements and the nodes are only red, and these always form a complete array. So it's never an issue with mesh correction 1. Whenever you are using mesh correction 2, you need to take care about how the n set and the element set at the boundary are written in the .inp file. Just write an arbitrary high number to complete the array. Then the code will automatically filter out that number. So this was the quick example about how to use this code effectively in reading an Abaqus.inp file, exporting it to MATLAB. All these codes are shared publicly on a public repository on GitHub. The link of it which I'll be sharing in the description below, so you can download it and use it instantaneously, and also edit it as per your need. If you have any doubts regarding the usage of the code or in some of the functions that I've used, you can just put down the comment below and I'll be happy to answer it. Plus, in the next video, I'll try to explain why are we doing this mesh correction. What is the need for mesh correction? Why can't we use the mesh data as it is from Abaqus? So please stay tuned and do watch the next video. Thank you.